Let's start with the very first term, which we see here, okay, which is ARM7 TDMI-ES. Okay, so ARM actually refers to Advanced Risk Machine. Okay, it's the company and architecture name. It's family of energy efficient RISC, which is reduced instructions set computing processors. Okay, 7 refers to ARM7 family. ARM7 is a popular and widely used generation of ARM cores. Okay, that is ARM processing units. T refers to thumb instruction set. It's basically compressed 16-bit version of the ARM instructions, which helps reduce memory usage and improves performance in memory constrained devices. D refers to debug support. This processor includes hardware debugging features. We can actually set breakpoints, step through the code and examine memory while running or halted. M refers to multiplier hardware. Includes a fast hardware multiplier which improves performance for math intensive tasks. Okay. Next we have I, which is ICE or in-circuit emulator. It allows debugging and testing while the chip is running inside a circuit. Okay, helpful during development. Last we can see S here, which is synthesizable core. What it means is it is described in hardware language like Verilog, which allows chip designers to integrate it into their own designs. ARM7 TDMI-ES is a compact and efficient processor core with small instruction set, that is thumb for smaller code size, built-in debugging and multiplication support, and the ability to be customized in hardware, that is the ES, okay, that we can see here. It's commonly used in embedded systems like microcontrollers, phones and industrial devices. Okay, so that is one important thing in the list of its features. Okay, let's see the other features now. Okay, at the top what we can see is it's nothing but ARM7 TDMS based high performance 32-bit RISC microcontroller. Okay, thumb extensions we have already discussed. What is this 32-bit RISC microcontroller? So when you say 32-bit, it actually means it can process 32-bit data. Okay, so the RISC here stands for reduced instruction set computer. Okay, it's a way in which your CPU is designed. Okay, then what we have is nothing but RAM details. 512 KB flash ROM. Okay, these are permanent storage to hold your program. Okay, you can code it even after the microcontroller is installed in a device. Okay, that is why it is called in system programming or in application programming. Okay, so is allowed. 32 KB RAM, that is temporary memory used while the program is running, like RAM in your computer. Speed, when it comes to CPU clock up to 60 MHz, it actually means it can process up to 60 million instructions per second, fast enough for many real-time tasks. Okay, on-chip crystal oscillator and PLL. These help generate the system clock and allows for accurate timing and frequency multiplication. Here PLL means phase locked loop. Okay. Next we have interrupt handling, and specifically here it is vectored interrupt controller. Okay, so this particular controller helps CPU respond quickly to important events like sensor input or errors by managing which ones gets handled first. Okay, when it comes to analog inputs, we have two 10-bit ADCs. Okay, analog to digital converters with 14 channels. Okay, it lets you read signals from analog sensors like temperature or light by converting them to digital numbers. Then we have different communication interfaces here like USB 2.0 full speed device controller. It lets microcontroller connect to a PC or other USB hosts. Okay, it has two UARTs, serial communication ports for talking to other devices like GPS modules or PCs. One of them supports full modem interface used in more advanced communication. Two I2C interfaces for connecting to other chips and sensors using two wires. Two SPI interfaces, another type of fast communication link often used with memory cards or displays. Then we have timers and clocks here. It has two 32-bit timers for counting time, measuring intervals, generating delays, etc. Watchdog timer, it helps reset the system if the software crashes or gets stuck. Then we have real-time clock, RTC. It keeps track of actual time, that is date, hours, minutes, even when the main system is off, and can be powered by a small battery. Okay, it has other peripherals like that is PWM, which is nothing but pulse width modulation. It is used for controlling motors, LEDs, or for generating analog like signals from digital pins. Okay, brownout detection circuits basically detect low voltage and can reset the system safely if needed. Okay, whenever there is low voltage. Then we have general purpose IO pins which can be configured to connect to buttons, LED sensors, etc. So in short, it's a very small, powerful, programmable mini computer with built-in memory, timers, converters and communication tools. It is ideal for controlling electronics, reading sensors, talking to other devices and managing real-time systems.